Today we're going to be learning about geometric sequences. A sequence is a pattern involving an ordered arrangement of numbers, figures, letters, or other objects. And we are given several geometric sequences here, and we're going to determine the pattern of the sequence and write a rule to describe it. So let's start with A. We have 525, 125, and 625. It looks like each time as we move forward, we're multiplying by 5. And so to find the next three terms, we'll multiply by 5. 625 times 5 is 3125. And 3125 times 5 is 15,625. On the next one, we have 192, 96, 48, 24. Looks like maybe we're dividing by 2 each time. 48 divided by 2 is definitely 24. And so we'll continue dividing by 2 to complete the pattern, which 24 divided by 2 is 12, and 12 divided by 2 is 6. On our next one, 81, 27, 9, and 3. Looks like we're dividing by 3 here, so 3 divided by 3 is 1, and then 1 divided by 3 is 1/3. And then finally 2, 8, 32, and 128. Looks like we're multiplying by 4 each time. 128 times 4 is 512. Then 512 times 4 is 2048. So for a geometric sequence, you can find the next consecutive term by multiplying some constant value called the common ratio by the previous term. Now on all of the ones up above here, we have multiplied or divided, but according to the definition of geometric sequence, we are multiplying. So on the ones where we divide, we are actually multiplying by the reciprocal of the number. So for A, the common ratio is 5, and for D, the common ratio is 4. And those are pretty simple because we multiplied those. But for B and C, because they were division, we have to write those in terms of multiplication. When you divide, you're really multiplying by the reciprocal. So the common ratio for B is 1/2, and the common ratio for C is 1/3. Geometric sequences are similar to exponential functions, and we can view them sort of like an input-output table or an x-y table for a function, where the term number n is like the x in a coordinate pair or the input value, and then the term that's in that position is like the y or the output value for that function. And we'll talk more about connections between those two later. So those term numbers just start with 1, and they're like those number dots that you stand on when you're getting on a ride at a theme park, and they just tell you what position in line you're in. Then the term a sub n is the actual number or item that's standing in that position in line. In this case, it looks like we're multiplying by 6 to move from term to term. Our first term is 1, our second term is 6, and our third term is 36. We'll continue the pattern by multiplying by 6. 36 times 6 is 216. And then we'll multiply 216 by 6 to get our fifth term, which is 1,296. To find the common ratio for a sequence, we can divide any term by the previous term. So if I'm looking at the problem above that we were just working on, and I couldn't tell by just looking at the numbers the pattern that was happening, I could take any term and divide it by the term before it, the previous term, and that will give me the common ratio. So the common ratio here would be 36 divided by 6, which is 6. And so we can solve to find the common ratio for any pattern when it's not clear by just dividing any term by the previous term. So here at the bottom of the page, we see the explicit formula for a geometric sequence. And you're probably wondering, why do I care about a formula? I can multiply or divide to move on to the next term in a sequence, and that's pretty easy. But if we look at the sequence at the bottom of the page, we see this 2, 4, 8, 16 pattern here. It's easy to identify some of these early terms. For example, the third term is 8. And the fifth term, oh, I don't know the fifth term, but I could probably figure that out pretty easily. The pattern that's happening here is that we're multiplying by 2. So I could find the fifth term by multiplying 16 by 2. That gives me 32. And I need to know the seventh term now. Okay, so here's my fifth term was 32, and my sixth term is going to be 64, and so my seventh term is going to be 128. So no big deal. Again, if we think about those terms like those little numbers that we're standing on in our theme park, you know, here's term number 1, here's term number 2, number 3, 4, 5, 6, 7. Okay, no problem. The first term, easiest one of all, the first term is 2. No worries there. However, what if they're asking us to find the 54th term? That's a long way down the road. That's a whole lot of multiplying, and it's pretty inconvenient and tedious to multiply 54 times on your calculator. So this is where it comes in that we want to be able to use the formula. If we want to be able to find the 54th term, that would be the nth term that we're looking for. We will just substitute the first term into the formula, along with the common ratio, the number that we find when we divide any term by the previous term, and we can plug in the term number, so in this case, that 54 number, for n into the formula, and that will give us the 54th term. The explicit formula is helpful when we're going way down the road and finding a term that's far away. So we just need to know the common ratio, then our first term, and we'll substitute those into our formula. Here we go. So I'm going to write the formula at the top of the page here so that we can take a look at it. So a sub n, that's any term that we're looking for, equals a sub 1, that's the first term, times r to the n minus 1. So here we go. Determine the common ratio for the sequence, and the sequence we were working with was 2, 4, 8, 16, etc. So we're going to determine our common ratio. Again, just in case you forgot, you can take any term divided by the previous term, and that'll give us our common ratio. In this case, it's 2. And then we will substitute the ratio and the first term, which in this case is 2, into our formula. So a sub n equals a1, which is 2, times r, which in this case is also 2, to the n minus 1 power. And this is a general formula that would give us any term that we were looking for. So after that, if we want to find the 54th term, we're looking for a sub 54. That's our 54th term. So we want to plug in the n value to be 54 because we're looking for the 54th term. And this a sub 54 will represent what we're solving for. So here we go. A sub 54, which is the term that's standing on the 54th position in line, equals 2 times 2 to the 54 minus 1. And then we will evaluate 2 times 2 to the 53rd power, and that will give us a very large number. 1.801E16 is what my calculator says. This is scientific notation when you see that E. So our 54th term is 1.8 times 10 to the 16th power. Let's practice writing an explicit rule for a sequence. Our first sequence given, for example A, is 3, 6, and 12. So our first term is 3. And then we want to find our common ratio. So we'll take any term, maybe 12, and divide it by the previous term to give us 2. Then we'll substitute a1 and r into our explicit formula. Again, a sub n equals a1 times r to the n minus 1. a sub n equals first term times r to the n minus 1. And that's our explicit rule for example A. For B, our first term is 400. Our common ratio, we'll take any term divided by the previous term. In this case, we get a fraction, 1/2. This makes sense because the number values are decreasing as we move through the sequence, and so this is a decay function, and the values are decreasing. So now we'll substitute. So our function, or our explicit rule, will be a sub n equals first term times r to the n minus 1. Next example, our first term is 40. Our common ratio, I kind of don't like these fractions, so I'm going to go with these two numbers, 10 divided by 40, and that simplifies to 1/4 for our common ratio. So our rule will be a sub n equals first term times the common ratio to the n minus 1 power. Pause the video now and try the next 3 examples on your own, and then check your answers to see if you got them right. Notice on these problems where the signs change from negative to positive to negative, etc., your common ratio is going to have a negative value. This is just an important thing to note as you're moving forward because it's a common error that students make. For example 3, we're going to create an explicit rule and then use the rule to find the nth term. All right, so step 1, for example A, to write the explicit rule, we need to find the common ratio, which in this case I'm going to do 4.5 divided by 1.5, which is 3, and then the first term, which is 1.5. I'm going to substitute those into my formula for my explicit rule, a sub n equals the first term times r to the n minus 1. So there's my rule for this sequence. Now I'm going to use the rule to find the nth term. So in this case, my nth term is the 7th term. I'm solving for the 7th term right here. So a sub 7, or the 7th term, will be found by using our rule. And in the place of n, we will substitute 7 because we're finding the 7th term. So we'll evaluate 1.5 times 3 to the 6th power. And that will give us the 7th term, which is 1093.5. Let's try example B. Our first step, we'll write our rule. The common ratio, 48 divided by 72, which is 2/3. And the first term, which is 162. So a sub n equals the first term times the common ratio to the n minus 1. Then we'll substitute for the nth term. In this case, the value of n is 8. We're looking for the 8th term. So that'll be right here once we substitute. So a sub 8 will give us the 8th term, 162 times 2/3, and then we'll substitute the value of n up here. So that'll be 8 minus 1. So our 8th term will be found by evaluating 162 times 2/3 to the 7th, which is 256 over 27. Up next, finding terms using an explicit rule and also using the recursive formula for a geometric sequence.